Hi everyone, welcome to mosfet.com. So in today's video, we have been given one question which is based on the opamp. You can see this opamp is drawn and input is applying on the non-inverting terminal. At V out, some resistance and current source is connected, and in question it is asked to find out the V out value in two separate cases. So in first case, we have to assume that the gain of this op amp is infinite, that means op amp is ideal, then what will be the value of V out? And when gain of this op amp is finite, that means 20, in that second case, we have to find out the V out value. So let's start solving this question. Let's for the first case where we are assuming the gain of this op amp is infinite, that means op amp is ideal. So we know that once op amp is ideal, we can apply the concept of virtual ground in the op amp. Since op amp is ideal, so we can see that there won't be any current going inside the input terminals. So I would be zero here for plus terminal also and for negative terminal also. So whatever voltage we have applied here at the one end of the resistance, same would be coming here also. So V in will come here also. Now, because of virtual ground concept in op amp, we know that due to virtual ground concept, I can write V plus would be equal to V minus. So whatever potential will come at non-inverting terminals, the same will go at negative terminal also because of the virtual ground concept. So this voltage I can consider as V in now, and there won't be any current going inside the op amp because this is ideal. So now at this particular node, if I apply KCL, so I can write V out minus V in divided by 5 kilo ohms is equal to V in divided by 5 plus 2 milliamps. Right, whatever current is incoming, that is being split into two parts. So that's what we have written here. This is KCL we have applied at this particular node. If I solve it further, so we can write V out minus V in is equal to V in plus 10. 5. We have taken LCM, so it will become 10 and 5 will cancel out. Now, if I write it, so I can write V out would be equal to twice of V in plus 10. This would be the answer of V out for first case where we are assuming the gain of this op amp is infinite and it is behaving as an ideal op amp. Now we need to solve this question again, but now we need to consider instead of infinite, gain is 20. So as soon as we will make this as a practical op amp and it's having a finite gain, we cannot apply the virtual ground concept in that case. That means we can't say this terminal voltage would be same as this one. So for second case, we know that V out can be write as KV V plus minus V minus. So whatever differential gain we calculate, that is basically the ratio of V out divided by V in. This is the differential gain, and V in is basically the difference of positive voltage and negative voltage, non-inverting terminal voltage minus inverting voltage terminal. And V out we need to calculate, and AV is given to us. So V out I can write as 20 is given to us. V plus minus V minus we need to calculate. So this is the V minus potential now. Instead of V in, I will call it as V minus. And V minus, again, in order to calculate V minus, we can apply the KCL here. So V out minus V minus divided by 5 would be equal to V minus divided by 5 plus 2. So again, I can write V out would be equal to 2V minus plus 10. Right? And if I calculate V minus from here, so I can write V out minus 10 divided by 2 will be equal to V minus. So from here, V minus value I can put here, and V plus is basically V in only. So I can replace V plus with V in minus negative voltage. I can write it as V out minus 10 divided by 2, and again this bracket. So 20, this will become twice of V in minus V out plus 10 divided by 2, and it will cancel out and we'll get 10 here. So I can write as V out is equal to 20 of V in minus 10 of V out plus 100. And if I bring this here, so ultimately I will get V out would be equal to 20 V in plus 100 divided by 11. So this is the answer of second part, where it was asked to calculate the value of V out in the case of finite gain. So this was an easy question, but the trick was here that once your gain is finite, how you deal with the calculation of this differential gain and how you deal with the positive and negative terminal. So these kind of questions are quite common in GATE exam also and even in analog interviews. So you should have a very clear-cut idea about opamp and how virtual ground concept can be used in infinite gain or ideal opamp case, not in the finite gain case. Thank you so much for watching this video. If you have any question, you can put in comment section. If you found this video useful, please share with your friends. Please like this video. And if you haven't subscribed our channel, please do subscribe. Thank you.